Welcome back to the deep dive. All right, based on the sources you shared, our mission today seems pretty clear. We need to really get our heads around classes, prototypes, and inheritance in JavaScript.
Yeah, exactly. This is sort of the final piece of the puzzle for JavaScript's object model, right? Objects, functions, and now classes.
And getting this right, well, it directly links to memory efficiency, which is super important for things like Lightning Web Components.
Definitely. So to understand the modern stuff, the ES6 classes, we kind of have to start with the foundation first, prototypes.
Right. The way things worked before ES6 gave us that nice class keyword.
Exactly. Prototypes were the core way JavaScript handled inheritance. Basically how one object could borrow or, well, inherit properties and methods from another.
Okay, so if I try to access a property on an object and it's not directly there, JavaScript doesn't just give up. It searches.
It searches. There's this implicit path, the prototype chain. First, it looks right on the object instance itself. If it's not there, it then jumps up to check the instance's prototype. Still no luck. It just keeps following that chain link by link.
Until it hits the very top.
Until it hits the end of the line, yeah. Which is the ultimate ancestor, object.prototype.
And that search path, that's where the big memory-saving idea comes in, isn't it? The exam tip you mentioned.
That's the absolute key takeaway. Because of this chain, you almost always want to define your methods on the prototype.
Oh.
Or, inside the class definition, which does the same thing now.
Why? Because then you don't duplicate the code.
Precisely. Imagine you have thousands of instances of an object. You don't want thousands of copies of the same calculate interest function sitting in memory.
Okay. You want one single copy on the prototype.
Yeah, and all those thousands of instances just point to that one shared copy. That saves a huge amount of memory. That's the whole point.
Okay, I think the animal and pig example helps here. So the pig object is created using object.create animal, linking its prototype to animal.
Right.
So when you call pig.makeSound, the method itself is actually living on the animal prototype.
Correct. It finds it up the chain.
But, and this is the cool part, this keyword inside makeSound still refers back to the pig instance, right? So it says oink, not whatever the generic animal sound is.
Exactly. The method location is separate from this context. It finds the function on the prototype, but executes it on the instance.
That separation is fundamental. And it leads us straight into the modern way because we don't often write raw object.create stuff anymore.
Not usually, no. So how do we get this memory efficiency using today's syntax?
With ES6 classes.
Yeah.
And here's the big thing the sources stressed. Classes are essentially just syntactic sugar.
Sounds nice, but what does that actually mean?
It means they look familiar, especially if you come from Java or C#, but underneath, they don't fundamentally change that prototype inheritance mechanism we just talked about. It's still prototypes doing the work.
Okay, so it's a cleaner syntax for the same underlying process.
Yep. And that distinction leads directly to a major exam trap or just a common mistake.
Let me guess. Where you define the methods.
Exactly. If you define a method inside the main class body, like a normal getDetails method.
JavaScript automatically puts it on the prototype. Efficiently.
Right. But if you define a method inside the constructor using this .myMethod function.
Oh yeah, that's bad news.
Huge anti-pattern, because now you are duplicating that function definition on every single instance you create. You lose all the memory benefit.
Right, you're back to square one, essentially negating the prototype system. Okay, so to do this properly with classes, we use extends and super.
Yep, extends is what creates that formal link. It says this child class inherits from that parent class's prototype.
Got it. Sets up the chain. And super seems to have a couple of jobs.
Two really important mandatory ones. First, inside the child class's constructor, calling super has to be the very first line.
Like literally the first statement. No setting other properties first. Nope. Got to be first. It's what initializes this context by running the parent constructor. If you don't do it first, this isn't available yet.
Okay. Mandatory first step. What's the second use?
When you override a method from the parent, let's say car extends vehicle and both have a getDetails method. In the car's getDetails, if you want to include the parent's details, like the make and model.
You call super.getDetails.
Exactly. You call super.getDetails to get the Ford F-150 part, for instance, and then you add the car-specific stuff, like in red. It lets you reuse the parent's logic.
Nice. So extends, links the prototypes, super in the constructor initializes this via the parent, and super.method name calls the parent's version of a method.
You got it. And understanding this whole structure that classes are this convenient layer over the efficient prototype system is just, well, vital for writing good, reusable, memory-conscious code, especially relevant for LWC, like we said.
Yeah.
Absolutely. It connects the modern syntax back to the core principles of how JavaScript manages objects in memory.
Okay, so we've covered prototypes, classes, inheritance, the keywords. But maybe a final thought to leave folks with.
Yeah, how about this? If ES6 class is really just syntactic sugar, making things easier to read, what happens when something goes wrong, when you're debugging?
Good question.
Do you debug thinking about the nice, clean class structure? Or do you mentally have to peel back that sugar coating and trace the problem through the actual underlying prototype chain search path?
Yeah, that's the challenge, isn't it? Knowing both the abstraction and the reality underneath. That tension is probably where true mastery lies.